Hi, in this section on soil carbon and soil organic matter, I want to talk about the impact of soil management on soil carbon stocks. And we're going to start in Africa, in Ethiopia, by thinking about the effect of forest clearance. So in a forest, you tend to have very tightly constrained or tightly coupled soil organic carbon flows. So the forest is growing, producing leaves and leaf litter and woody material that's falling onto the forest floor, being decomposed, releasing nutrients, and so that cycle is quite tight. There's not much organic carbon lost as the trees take up the organic carbon and then release it back to the soil again. However, when you disturb that system by going in and removing the trees, perhaps by clearing it for agriculture or for plantations, what you find is that you get a very rapid decline in the soil organic matter over quite short periods of time. And here we've got a study, as I mentioned earlier, from Ethiopia, and we have where the scientists have gone out to areas which have been cleared at different periods in the past and measured the organic carbon in grams per kilogram of that soil. And the top line here is the total amount of organic carbon. So you can see that it declines initially quite rapidly and then begins to level off as a new equilibrium is reached. So we've got a kind of an exponential decrease in the amount of soil organic carbon in the soil over time. If we look at the two components, obviously the additions of soil organic carbon from the forest stop as soon as you clear it, but there's still organic carbon left in the soil, and we talked about turnover times in an earlier one of these mini lectures. And so here you can see initially there's a rapid decline in the amount of carbon within the soil coming historically from that forest carbon, but it then begins to level up as we end up with material which is either more recalcitrant or is perhaps protected with inside soil aggregates. The converse is true in terms of organic material coming from the crops. So often the system, probably maize is being grown, but it might be beans or cassava or some other crop in this area. And obviously that crop has roots, it has leaves, it has stalks, which are not normally interesting for somebody who's farming it for food. And so that material may be returned to the soil. So as the crops are grown, we start to see an increase in the amount of organic matter which is coming from the crop. Obviously at the beginning, when the forest was cleared, there was no organic matter from the crop, and then it rises exponentially to a new equilibrium value. And so we add these two components together and we would get to the amount of soil organic carbon in the soil. So clearing forest is not usually a good thing in terms of soil organic carbon stocks. It leads to a decline. In this case, almost 50% of the carbon that was in that soil is now in the atmosphere. Okay, so by breaking up the soil, allowing that carbon to be accessible to microbial decomposition, we've seen the release of carbon dioxide into the atmosphere and a reduction in the soil organic carbon. Let's go to the US now, to a really famous experiment at the University of Illinois, the Morrow plots. So this was a long-term experiment which was set up way back in the kind of 1880s, where they looked at what would happen to soil organic matter or soil carbon over time following the conversion of what was a prairie grassland into either maize or corn and oats and clover rotation, or continuous corn. And so you can see here the blue line is samples taken from what's called the bluegrass border. So this is kind of equivalent to the grassland that would have been there when they created the plots and started agriculture on the site. Here we've got the two treatments, the corn, oats, clover rotation, and the continuous corn. And you can see that in both the treatments which involved continuous agriculture, you're seeing a decline of, probably getting on for 50% of the carbon from in the continuous corn treatment. So conversion of grasslands to agriculture is also going to release significant amounts of carbon into the atmosphere. So if we come a little closer to home, at Rothamsted Experimental Station, which is just north of London near Harpenden, been established for over 100 years with some very long-term agricultural experiments. And this is an experiment where grass was converted to arable agriculture and arable was converted to grassland in around 1950. And what you can see is that the grassland that has remained in grass has gradually increased its soil carbon content, but where it was converted to arable agriculture, its carbon content has reduced rapidly and then started to kind of to become close to the content of that site which was left in arable for the whole period of the experiment. And then you can see the plots which was started, it's getting a bit flighty, you can see that the plots that were started in arable agriculture and then converted to grassland have seen their organic matter rise very rapidly and approach the equilibrium of the plots which started in grass. And this has taken a time period of around about 50 years. The arable plots which were left in arable just seen a kind of steady levelling or even slight decline in soil organic matter over the same period. Why is this important? It's important for two reasons. The first one is that if you convert grassland into arable agriculture, you're going to get a dramatic release of carbon dioxide. The second one is if you go from arable agriculture back into grassland, it's going to take you some time to reach that grassland equilibrium. In this case, at least 50 years. The other thing to note, I think, about when we try to manage soil carbon stocks is that you need to add a lot of carbon to change the soil's carbon content. And so if you're thinking about manure inputs or perhaps dung inputs from having grazing livestock on the soil, you'll see from the graph on the left-hand side that you need an input probably in the region of 150 to 200 grams per metre squared per year. And this is going to equate to around about 10,000 grams per hectare, or if we think about that in kilograms, probably about 100 kilograms per hectare per annum of carbon going back to the soil just to remain at equilibrium. So significant amounts of either manure or animal dung required if you want to build soil carbon stocks. So this is just another shot from Rothamsted, this time taken from the Broad Bulk Continuous Wheat experiment. You can see it in the background of this slide. And here we can see the effect of adding farmyard manure every year to the soil. And what you do see is that you do increase soil organic matter, initially rapidly, a bit like the grassland situation. You start to add lots more organic matter into the soil. You start to see a rapid rise, and then beginning to kind of flatten off. And bear in mind, this is a 100-year period, so these are significant amounts of time. Where you've added nitrogen, phosphorus, and potassium fertilizer, you see a very slight rise, and that's due to better crop productivity and therefore more material being returned to the soil in the form of leaves, shoots, and roots. Where it's been unmanured and nothing has been no fertilizer has been added, you see a decline in the amount of organic carbon in the soil due to lower productivity of those crops, returning less material to the soil. So how long does that effect of adding that farmyard manure last? So this is another experiment at Rothamsted where farmyard manure had been added since perhaps the 1850s, and then they stopped adding it in around 1880. So the interesting thing here is that if you continue to add farmyard manure, as we've just seen, your soil carbon contents continue to rise. Great. If you stop, they begin to decline. But me being an optimistic person, I would think that this is actually a good news story, because we still haven't reached the levels of of soil organic carbon in those plots which never receive farmyard manure. So I think there's a positive story here that even adding farmyard manure over a 20-year period in the mid-19th century can still have a residual value to your soil carbon stocks when we get into the 21st century.